Hi everybody, here is a quick video on Algebra 1 end of course exam review. This one is recognizing the four functions commonly studied in Algebra 1 from their graphs. And the goal of this video is that you should be able to recognize the four functions just by looking at their graphs. Here's a quick warm-up for you to do in order to be ready to fully understand a lot of these topics. So take some time now, pause the video, and see if you can 1. Create a table for the following equation, and 2. Determine if the table is linear. If you're having trouble with determining if the table is linear, see my earlier video, checking for linearity. Alright, so give the video a pause and give these a try. Alright, here we go. Here come the answers. For the first problem, there are the outputs you should get. You should notice that they're symmetrical, and 1, 9 is the center. For the second table, you should analyze the rise and the run, and when you look at those ratios, you should say that that is linear, which means the function is constant, and the slope is -6. So in Algebra 1, we focus on 4 types of functions in general. Each type of function has a unique pattern that exists in the real world. You're going to have to be able to look at these and recognize them from a table, an equation, or a graph. The 4 function types are linear, exponential, quadratic, and absolute value, and those names should mean something to you already. A linear function is one that changes consistently. We say that they have a constant rate of change, and that change is so important that we gave it a special name. We call it the slope. That describes the change of the linear function. Recognizing the graph of a linear function is quite simple. The graph of a linear function is a straight line that has no curves, no turns, no bends, and no holes. So it should continue on forever. For linear functions, you'll often be asked to find the slope and tell if the graph is increasing, decreasing, or neither increasing nor decreasing. The pattern for the slope that you've no doubt learned is rise over run. So, types of slope. If a graph increases from left to right, we would say that it is a line with a positive slope. If a line is decreasing from left to right, we would say that it has a negative slope. Horizontal lines have a slope of 0 because there's no rise, and vertical lines have undefined slope because there's no run. If there's no change in the x value, it would be rise over 0, and you can't divide by 0. Another way to talk about a horizontal line is to say it's neither increasing nor decreasing, or simply that it is constant. The next type of function is the quadratic function. The shape of a quadratic function is called a parabola. We remember quadratic functions by thinking that they look like the letter U or the letter N. If it looks like a U, we say that that's opening upwards because the opening is at the top. If it looks more like an N, we say they open downwards. Both are nonlinear functions and they don't have slope because they're not linear. If you're asking yourself, can they go this way? The answer is no, because that would not be a function. See a later video for what a function is or isn't. Alright, next, an absolute value function. An absolute value function are the closest to being linear. In fact, each half of the function is linear. However, the function is not linear. The graph changes directions at its vertex, which is either going to be its minimum or its maximum. These open upwards and downwards similarly to the quadratic function. Both of these are nonlinear, even though they look linear for half of the time, and they don't have slope because they're nonlinear. They break the rule that they are not supposed to turn to be linear. These do turn, so they are non-linear. All right, finally, the exponential function. The exponential function changes slowly at first and then quickly. So if it opens upwards, it increases slowly at first and then quickly. If it opens downwards, it decreases slowly at first and then quickly. One thing that's important to notice is that this part over here on the left side looks like it's just flat constant at 0, and that is not true. That graph is increasing a tiny, tiny bit at a time. It just doesn't look like it. These are nonlinear because they are turning, and they don't have a slope because they are not linear functions. All right, I hope that video was helpful to you. Feel free to put questions in the comments. All right, see you later, folks.